a pleasure to be here. When I was asked to speak today, my first response was, where is it? And when they said Raleigh, I said, sign me up. I could be talking about peanut shells. I'll be happy to talk locally. Prior to the shutdown in March of 2020, I was one of those people that traveled anywhere from 150 to 200,000 miles a year around the world. And I went from that amount of travel to nothing in a heartbeat. And I kind of got used to it. It was kind of nice to kind of be home and actually realize I had 3 kids and a wife, and be able to benefit from the productivity of working from home and doing all those things that connectivity kind of brought to bear. And quite frankly, I've just started kind of like going back out on the road a little bit more, and I was at the Intelligent Traffic Systems conference in Charlotte earlier this week, which I was able to drive to go and do and participate in. But man, when I got back, I felt like I had walked home from Charlotte. I'm so out of shape for this getting back on the road travel routine. So happy to be here in Raleigh talking about connected communities and the horizon, if you will, that we see at EdgeX and the unique vantage point that we have as an early stage software company. The use cases and the technology that's been presented so far this morning are fantastic examples of what's happening on the ground in the field. What I'm going to do today is kind of back it up a little bit. I'm going to talk a little bit about what it means to be a connected community and what the sort of the common denominator is for a connected community. But I'm going to bring it back a little bit to the macro and look at some of the unique challenges that connected communities are going to present as we think about scaling this, right? We're doing connected communities now in these, I don't want to use the term silos, but community by community. There's lots of pilots. There's lots of discrete single-tenant use cases out there. I'll bring it back to some of the considerations that we have to think about if we're going to truly scale this nationwide or worldwide or planet scale, whatever term you want to use. So I think from the perspective of what it will mean to be a connected community, there's lots of use cases, lots of examples to talk about. Rob did a great job talking about the digital divide. I know right here in Wake County, the amount of students that don't have access to adequate broadband in order to engage in education and learning is an alarming number. It's a serious concern. It's something we have to address. The ambitions for Vision Zero and traffic safety and what have you, top of mind, top of list in terms of priorities as a connected community. But I think what underpins a connected community is this progress towards greater intelligence, greater awareness. If we have greater intelligence and greater awareness, the kinds of innovative software solutions that have been presented can begin to develop and flourish in our communities. So kind of bringing it back a little bit, as I said, I'll bring it back to the macro and talk a little bit, and then bring it back down to, the things on the ground that are happening. I like to think about, what we're involved in at a macro level in the context of how the internet itself is evolving, right? Everything that we've seen today relies on networks and specifically the internet. And I'm old enough to have lived through now multiple generations of the internet as an entrepreneur. I began in the 90s when the internet was in its infancy. I lived through the dot-com era. I made money and lost money like I'm sure everybody or most people in this room did in the dot-com era as we progressed to connect hundreds of millions of nodes and expand the network that was the internet. I made my career really in this cloud computing era, or this third generation of the internet, as we've connected up billions of smartphones and computers online. But that's not actually the end state. The end state is not where we are today. The end state is what's coming next. And what's coming next presents both opportunities and massive challenges for connected communities. We're talking about really the era of connected machines. And in this era of connected machines, and you can argue about the number or debate the number, I thought it was going to be hundreds of billions of machines and sensors that we're going to be connecting up. But the reality is that, no, it's actually close to 1 trillion. I sat in a presentation with a processor company not so long ago, and they talked about 1 trillion of their processors being in smart sensors by 2030. And immediately I realized that I underestimated exactly how significant the fourth internet was going to be, this Internet of Things, right? It's this era of connected machines, as it were. So the kinds of applications, I won't go into a lot of deep dive because this has been covered by Rob and JP at length, but intelligence and autonomy are going to define the fourth internet applications. All of the use cases that you've seen so far are all about intelligence. They're all about using sensors and connected machines, to apply machine learning and artificial intelligence to create an output that makes a community ultimately smarter, more intelligent. These are the applications that are going to define them. And it's really different than the applications that we're used to now, right? The applications we're used to consuming in the third internet are, our applications like social media and mobile apps and what have you. But this pivot that's happening in the fourth internet with software is this pivot from this abstract, Google spreadsheets and social media to a very real world application where the software can be responsible for life and death. It can be responsible for poverty and wealth. It can be responsible for life-changing, life-altering decisions that can be made in the field. And that's a fundamentally unique difference between applications that we're encountering now versus what we live in today. And so if you play this out, right, all of these sensors that companies like NTT and Dell and what have you are wiring up, what they do is they create data. They spit out data, okay? And that data is ultimately processed into intelligence, and intelligence creates value. So if you play that out, it seems pretty logical to rationalize that data really is the currency of the future internet, of the fourth internet. And there's going to be a lot of it. Okay, so we've talked about some really cool use cases here today, but if you play that out, if you multiply that out across every community across the country, we're talking about an inordinate amount of data, right? And we talk about zettabytes and petabytes and exabytes, and people go, I don't know what that is. So what I did is I kind of did a back of the napkin exercise to kind of quantify that in a more of a material sense, right? So 1 petabyte of data, okay, is roughly 2 data center cabinets of ultra-high density storage. So think your data center rack times 2, that's about 1 petabyte of information. 1 exabyte of information is 2,000 of those, okay, and that would fill up about a 4-story data center, in a city block, right? And if you're kind of keeping score of that, what I'm doing is I'm adding back of the napkin math to the cost of this infrastructure to store that amount of information. 1 zettabyte is about 1,000 data centers, or about 20% of the island of Manhattan completely filled with hard drives, right? About $250 billion in CapEx in order to store just that, okay? Now, going back to that previous slide, we have line of sight now over the next several years to 250 zettabytes of information, okay, in the fourth internet. And what that ultimately means is that storing just 10% of the data that the fourth internet is going to create will require over $60 trillion of new infrastructure spending. That's both an opportunity and a challenge on multiple levels as we think about connected communities across the country. And so from our perspective at EdgeX, and why I kind of got into what I'm doing is because I started to look at how we're going to process that data, how companies like Dell and NTT and others are going to be able to process that amount of information and do so in an amount of time that's going to make those solutions work, given the fact that we're moving from this era of abstract applications to the very real world. And so today, and again, how I built my career in cloud computing, I understand how applications run and where they run. They run in centralized cloud computing data centers, and we backhaul information, whether it's from my laptop at home or from the city intersection or what have you. I backhaul lots of data to a centralized cloud for processing so intelligence can be created. Fantastic. And generally speaking, we live in a world of 10 to 150 milliseconds of latency, and up to this point in time, that's been generally okay. We've been okay with living with that. But as we look forward to these applications at scale, we're going to have a latency problem, right? When we work with intelligent traffic systems companies, what they're telling us is that what we have to achieve is less than 5 milliseconds latency. And that's not just ping, that's processing. Okay? And it makes sense. Like, do you really want the pedestrian detection algorithm to take a bunch of time? You can't live with that kind of solution. So latency is a very big deal. What we're going to have to do as an industry, as a community, is put computers in much closer proximity to all of these connected things, right? That, by definition, is exactly what the edge is, right? So depending on who you talk to in the industry, the edge means different things. Well, to me, the edge just means a high-performance computer located in close proximity to a connected thing. If you take the amount of infrastructure that's required to process all the data in the fourth internet, we're talking about a boatload of servers, okay? A boatload of infrastructure. We're going to need millions of computers, okay, in close proximity to the billions of connected sensors. And that's both, like I said, both the challenge, and an opportunity. And as you probably know, entrepreneurs are usually gamblers, right? So as an entrepreneur, it's irresistible for me to try and take that challenge on. I almost can't say no to it. So just a little bit of an understanding about where the edge is, right? Because again, depending on who you talk to, you'll get a different answer for this. And we kind of define the edge as everywhere within a connected machines, everywhere within a connected sensor or device. But what you're going to start to see as we expand connected communities is that compute processing is going to be located in more and more weird-looking places. We just rationalized the third internet in terms of these football field-sized warehouses full of computers like Amazon Web Services and Google and Apple and what have you, the hyperscale data center market, if you will. And that's going to continue to exist. But as we look towards processing all of these applications in the fourth internet, computers are going to be located in weird places. We call them weird-looking data centers, cell towers, charging stations, small cells, IoT gateways, these micro, small edge data centers that you'll see popping up, and including traffic cabinets, right? When I started in the intelligent traffic system space, my first reaction was the metal box on the street corner. I don't know what it does, but to me it looks like a small data center, and that should be a data center for processing information in the fourth internet. Okay, so seems like a rational problem, seems like an easy challenge. We have lots of cloud computing companies out there. They'll clearly solve that problem like they solved the challenges that we had in mobile computing in the third internet, right? Seems obvious. I think we're out of time, I'm done. The cloud computing company's here to the rescue. Well, maybe not so fast, right? So this to me, is one of the biggest challenges that we'll face as we connect these communities up, is how to actually process all of this data. And so if you think about the challenge, you have to understand a little bit about how cloud computing works and how we write apps today, okay? When I build an application, I build my entire stack, and then I provision it one time to a persistent location in the cloud, like an availability zone or some fixed server somewhere. But the challenge with the edge and the challenge with the fourth internet is that the applications and the data, the code and the data at the edge is now highly mobile. Right? These cars are moving around, pedestrians are moving around, and it requires location density, it requires point of presence density. I can't simply write an application anymore to one fixed location. And also, to do that at a multi-tenant scale is a whole other problem, right? It's one thing to do this with I have some computers located in some traffic cabinets and I am the only user of those infrastructure, but how do you do that at multi-tenant scale? How do you do that with millions of developers and software companies writing and innovating solutions at this far edge of the network? These are very weighty problems, but ultimately it will require a different kind of architecture to deliver cloud services. And this is, this kind of gets into a little bit about what we do and why we do it. So recognizing this challenge as software innovators and software entrepreneurs, what we set out to do at EdgeX is create an operating system that would allow for the instantiation of the kinds of cloud services that software companies like NTT Data, for example, will require at the far edge of the network. So being able to write, test, and deploy code at planet scale. So rather than provisioning to a cloud, provision to an individual machine, be able to stream sensor data. One of the biggest challenges that we've observed in the ecosystem today is this ability to stream data once, but potentially consume or make use of it across a plurality of users, rather than one fixed use case. But also secure the data. One of the biggest challenges I think that we'll observe in connected communities is how you achieve data integrity, right? So how do you ensure that, or assure that the code of the data that's being used for the application has never been tampered with, right? So securing that data becomes a key component. So we took all of that goodness and we packaged it down into a lightweight operating system that's deployable on any computer. Great, well now you actually have to connect those computers up. So what we also invented is a bit of a technical term, a peer-to-peer content address storage network protocol. Basically a fancy way of saying we can make those computers that run our operating system connect with one another and speak to each other all the time. And what they're saying to each other is, I have this coder data and I want that coder data, right? So they're exchanging the address of information and data all the time, so that when a request, right, comes into the network that says, hey, I need a little bit of that data that Rob is presenting, the network knows where to go and get it and bring it to you on a proximity basis. So we're solving the latency challenge, but we're also solving the backhaul challenge, because as you'll see here, there's no central point to this. There's no central cloud in the mix anymore. So having the benefit of a couple of years of doing this, we've found some interesting use cases, and I'll just highlight a couple that I think are kind of, they're interesting and they're important to connected communities, and then I'll kind of wrap this up by talking a little bit about how I think we have to scale this out across many communities across the country. So intelligent traffic systems, or ITS, is absolutely going to intersect, no pun intended, with the fourth internet. A lot of use cases in terms of that were presented today already in terms of wrong way detection and things like Vision Zero and traffic safety and what have you. So what we began to do is recognize, again, connected and autonomous vehicles are going to generate vast amounts of data, and that data will need to be processed on the street corner. So what we began to do is install our operating system on computers located in the traffic cabinet so that we can take a feed from a sensor like a camera and have the intelligence applied, the AI, if you will, applied on a computer inside the traffic cabinet, and the resulting output could be shared or distributed across a plurality of users. So in this particular case, you have the heads-up display via V2X to a connected or intelligent vehicle, and that data, might say something like, "Hey, brake the car," or reroute traffic, or what have you, reroute your path to your destination. But it's also information that's fed to centralized traffic control. And we're not here to say, oh, we write the algorithms that make the smart technology. Folks like JP and Rob do that or enable that at a granular level. What we're here to do is allow those solutions to scale at ultra low latency. And so, that's one example in the intelligent traffic system space. And the other thing that points to the need for this kind of technology is first responders. Right? We recently announced a solution with the Department of Defense that we called the Internet of Military Things. And yeah, I'm not a military guy. Before getting involved with the DoD, I knew almost nothing about the military aspirations or how technology was really applied in the field and how that might how that might relate to first responders in a connected community example. But what I learned from working with the DoD is that they share a lot of the same problems, in the sense that information superiority, intelligence is key. Right? If you're going to inform threat response to a warfighter, as an example, you better have all of the ingredients that we talked about located in close proximity at all times to a warfighter. And so that means putting computers inside of a personnel carrier, computers capable of executing the kinds of algorithmic solutions that are necessary to inform threat response. So in the past, the DoD would do something like, okay, the warfighter has a bunch of sensors on his or her person. Those things collect a bunch of data. That warfighter comes back to the forward operating base, unloads a bunch of that data, and then offline, that data gets analyzed, and there's a lot of post-mortem analysis that goes into understanding what happened, in a certain situation. And what we're trying to achieve in that context is a more real-time effect. So if the warfighter or the first responder, like EMS in a city, was able to have real-time threat response or real-time threat analysis, they could inform response in a much more intelligent way. And quite frankly, if those kinds of solutions saved just one life, it would be well worth the effort to build and develop. So what we launched with some partners in the military is this idea of an Internet of Military Things, this idea that a peer-to-peer network of computers could exist from quote-unquote base to battlefield, or in the connected community context, from central command right down to the EMS vehicles that are traversing the streets. Increased responsiveness, right? We want to improve agility, response times. We want to simplify operations, right? These things have to be inherently multi-tenant in order to scale, and ultimately be aligned on the goal of increasing the security of data and the integrity of data, right? The solutions that we've seen this morning are fantastic, but boy, oh boy, somebody better be talking about the security of that data at some point in the near future, because it's going to become increasingly important. And no greater use case, in my opinion, than what's happening in the DoD. Okay, so I'll pause there for a second just to take a sip of water. Like I said, having driven back from Charlotte, I feel like I walked back, and I'm a little bit sluggish today. So we'll pivot to some considerations for community planners and builders, like many of the folks here today. Okay, so I have a slightly different take on how we build massively scalable connected communities, as we look forward into this fourth internet. And I'm going to borrow a quote from a good friend of mine, Dave McCrory. In 2012, Dave came up with a really cool theory called data gravity, right? And what he said is that you should consider data as if it were a planet or an object of similar or sufficient mass, okay? And as data accumulates or builds mass, there is a greater likelihood that additional services and applications are going to be attracted to that data. Ergo, as the mass or density increases, so does the strength of the gravitational pull. What Dave was describing in 2012, or trying to articulate in more of a theory, was how third generation internet technologies like Salesforce, example, scale. There's a strategy there where if you create and publish data, my friends in the nerdery are going to come. Right? We're going to build cool stuff. If you give us data, we will build cool stuff. So it seems logical, as we kind of look forward a decade from when Dave published his theory called data gravity, that data gravity is not just a way to observe how technologies and software form. It's also a strategy, particularly in the Internet of Things, and particularly as we think about connected communities. I take that a little one step further into connected communities, and what I say is, data gravity creates economies, right? That's been proven time and time again. If there's data, there will be absent services, and the absent services are the ones that create economies. They're the ones that ultimately create prosperity. And economies, right? They create the opportunity. They create the innovation, right? So, we don't have to teach a case study on how Silicon Valley is Silicon Valley, or how Research Triangle Park is Research Triangle Park. We know that that the smart people and smart solutions, the investment pours into communities when there's opportunity, right? Where there's economy. And so, opportunity, right? If we just distill this down simply, is the foundation of creating a connected community. And that, to me, is a blueprint for every city, for every municipality, and even at a state level. Focus on creating the perfect storm of data. If you create the data, if you make the data available, particularly on a multi-tenant basis, you're going to attract all of the solutions to your community, and that's what's going to develop the intelligence and ultimately foster a connected community at scale. And so, and I think about this, from a macro perspective, right? So that makes a lot of sense. Data gravity, drives application and services attraction. That creates economies. That creates opportunities. But this isn't something new, right? We've lived this many times over as a society, Western society, in the last 100 years plus, right? We've dominated 20th century's economies by making infrastructure a national priority. Right? When I say infrastructure, I mean physical stuff, right? So we did this in electricity, right? The United States was one of the vanguard leaders in the electrification of industry, and the electrification of industry created an economy that was almost immovable for over a century, okay? We were, in this country, we were among the first to make national highways a federal priority, right, in the 1950s. And if you think about the economies and the supply chains that have formed around pavement, as an example, understanding how infrastructure needs to be a national priority should be relatively obvious. Where would we be without interstates and all of the roadways that facilitate commerce and opportunity at a physical level, right? We would be, I don't know, probably some Eastern European country or, second economy in the world. But no, we've been first because of this investment in physical infrastructure. And the same is true for the last 100 years of telecommunications, right? I think we take for granted just how important it was taking a leadership position in telecommunications over the last 100 years, right? The internet economies that I described in the first, second, and third generations of the internet, we're the epicenter for that, right? If we were living in Roman times, this would be Rome, right? We've created these economies by investing in infrastructure. So it seems obvious to me that the next big investment that we have to facilitate is the infrastructure for the fourth internet. It's the plurality of sensors that exist for, again, for JP and for Rob to build those really cool use cases inside the cities that they work with. And so, yeah, great. It needs to be a priority for the 21st century economy, the edge economy. How do we do that? And I'm a huge, huge, huge believer that public-private partnerships is the way for this to be done, right? I'm old enough to come from the vendor landscape of it's my solution and everybody uses my solution and you don't use the competitor solution. But that old way of thinking for developing infrastructure and scaling as we look at this new economy has to change, right? We have to change that. We have to be working hand in hand with the communities. And that doesn't mean selling technologies to cities and hoping that they have enough budget to cover what I have to do. No, what that means is an exchange of value. What public-private partnerships mean in the fourth internet is, look, a city has the necessary capabilities like rights of way and things like that are necessary for the infrastructure to take root and form economies. And so a couple of examples that I'll highlight before I wrap up of companies that we're working with. One is integrated roadways, fascinating technology. These guys are creating smart asphalt that will charge electric vehicles as it travels down the road. Fascinating stuff. Slabs of concrete of pavement that are filled with sensors that emit and create data. But rather than selling their technology to communities and saying, hey, if you've got the budget, if you're wealthy enough, you too can buy my solution, what they're saying is, no, look, you need to upgrade roads. Let us upgrade them for you, and we'll create this partnership built around the data that smart pavement creates. We're also working with a new company called 3Red8. 3Red8 understands that the fourth internet is going to require a new network bus. It's going to require fiber, coast to coast, in a different, end to end, in a different context of the way that we've laid fiber in the past for the internet. And they're beginning I'm happy to report, they're beginning the project right here at home in North Carolina and neighboring Virginia and South Carolina. And what they're doing is instead of saying, hey, somebody pay me to plumb fiber, what they're saying is, no, commercially we'll plumb the fiber, you give us the rights of way, and the benefit of having this kind of infrastructure in your community is going to foster economy. It's going to foster the kind of growth that connects the communities. And finally, I'll highlight our relationship with the Autonomy Institute in Texas. So our friends in Texas understand a really unique challenge in the sense that all of these sensors and all of this network infrastructure, okay, is going to create a potential problem in the sense that if every vendor in the tech universe has to put their own sensors at the intersection, it won't take long before every community, every connected community looks like downtown Bangkok. And if you've ever been to Bangkok, you know what I'm talking about. That's not what we want. We don't want that kind of technology blight. So what the Autonomy Institute is doing is focusing on how we co-locate all of those sensors into single locations called public infrastructure network nodes and work hand in hand with state and local officials to be able to deploy that infrastructure not on a pay-for-play basis, but on the basis of creating the foundation for fourth internet infrastructure to take root so that we can create the gravitational pull to build economies in our communities. So I've got about a minute left in this presentation. I'll kind of pause and provide my favorite quote from our mascot Sasquatch, who says, "Believe in yourself even when no one else will." I'm sorry, I'm a literary guy. I really fancy a delicious pun, and Sasquatch kind of hands that to us. If anybody has any questions, I'm happy to answer questions or make my way to the coffee stand. It's your call. Thank you for your time, though.
Hi, my name is Balu. I'm from SAM Analytics Solutions. When you think in terms of connected communities, in my mind, there are two essential fundamental entities, individuals and devices, right? Which lead to four possible connections, which is individual to device, individual to individual, device to individual, and device to device. when I hear smart city concepts that are being discussed, I see more of a device-based community that is being formed with a lot of intelligence and data and everything. Where is the so-called edge in terms of individual and device in your thinking?
So today, I mean, that, we kind of describe the edge in terms of computers or servers located in close proximity to the connected sensors that ultimately these applications can flourish on top of or build on top of. However, I believe in the future, as we kind of go beyond the next iteration of the fourth internet, that the edge will become us ourselves, right? I mean, there's more compute capacity in this smartphone than I ever had 20 years ago getting my education. And that compute capacity can be shared, it can be interchanged. I think that as we progress, the devices themselves that individuals carry around with them or drive around in their cars can participate in the edge economy. Now, we're not anywhere near ready for that, but that, to me, the ultimate plurality of connected devices working together to share resources in order to execute algorithms and code is where the future lies for smart cities and connected communities. All right, thank you.